Good afternoon to everyone in the room here in ITU, and good afternoon, good morning, good evening also to the remote participants, and welcome to this workshop on Geospatial AI. My name is Andrea Manara from the ITU, the International Telecommunication Union. It is an honor for me to introduce this workshop, which was organized under the leadership of Maria Brovelli, with participation of all of the stakeholders from academia, private sectors, member states, United Nations organization, to debate how to build a foundation for Geospatial AI. We realized a few years ago in the TU that the Geospatial component was missing in the AI for Good. Indeed, that there were some related discussions in some thematic areas such as climate science, but not focused on GeoAI as a discipline. So we had started a couple of related activities in 2022. We started the GeoAI Discovery Channel on the application of Geospatial AI and the relevance of it for the Sustainable Development Goal. And then also in parallel, we started a GeoAI Challenge, which is a competition which is aimed to provide solution for collaboratively addressing real-world geospatial problems by applying artificial intelligence, machine learning. And for the GeoAI Discovery Channel, we asked the 3 outstanding geospatial professionals to be the curators of this series. Nadine Alamé, Chief Executive Officer of the Open Geospatial Consortium, Maria Brovelli, professor from Politecnico di Milano and chair of the UN-GIS Academic Network, and Barbara Ryan, that is the executive director of the World Geospatial Industry Council. And then with this, we had gender balanced all of the curators from different discovery channels in one go, actually. And this GeoAI webinar series had discussed the many different topics like GeoAI application policies, ethics, the future of GeoAI for Good. And within the thematic sessions, we have discussed the climate actions, spatial digital twins, energy, ecology, earth, health, agriculture, water and food system, and education. And the recordings of all of those events are available on YouTube and on the Neural Network. Some of those events, like the workshops on satellite data analysis and machine learning classification with the QGIS, were attended by thousands of participants, flagging a real need for GeoAI education. And then this workshop on building a foundation for Geospatial AI is really at an appropriate moment in time. As ITU, we have been involved on GeoAI discussions with different geospatial partners within the UN Open GIS initiative, the GeoAI Working Group, the UN Geospatial Network, and the World Geospatial Industry Council that I see here very well represented. And we hope to keep strengthening our cooperation. Before closing my remarks, I would like to remind you that on Friday at 1 o'clock, Maria will be launching the 2023 ITU GeoAI competition in the SDG stage, the AI for Good. We have 5 problem statements this year, the one from FAO, and UNODC on crop mapping. We have from Qatar Computing Center Research Institute and QN Labs Inc. on location mention recognition from social media for disasters. With the European Space Agency, we have a competition on estimating soil parameters from hyperspectral images. And then we have 2 problems from the Politecnico di Milano, which are also related to climate change, one on landslide and one on air pollution. And of course, I would be very much pleased to discuss with all of you of any possible involvement on these activities. So I I thank you very much again for being here, particularly to all the panelists, and welcome again all of you in the ITU. I wish you a very successful workshop, and I give the floor to Maria. Thank you very much.
Okay, so thank you, Andrea, first of all, and thank you for being here. I want to start thanking the people of ITU because it was a long journey for arriving here. We started a couple of years ago discussing about the opportunity of having special series related to geospatial AI. And I believe that in the end, it was very successful, was good to have the possibility of working together, people from the academia, people from the private sector, and obviously the agencies of UN in this field, which is new. And I believe that at least as educators, one of our exigencies is to better understand how we have to teach, what we have to teach, and how we have to teach to our students in order to prepare them for their future work. So this is my main message. This is not a workshop where everyone show how good we are, what we did. It is a starting workshop, is a starting path, because we want really to build something for everyone, for the students, for the future generation, I believe, in principle, but then for the academia, the private sector, and everyone. So be very relaxed, because it's not a place where we have to demonstrate something, it's a place where we have to discuss about what we want to do in the future for building something. Okay, so I will start this presentation showing you, after some presentation, I will show you the results of the survey that as a UN-GIS academic network, we sent around to universities collecting outcomes with respect to geospatial AI. So before starting, I want just to recall you what is UN-GIS, because I'm chairing the UN-GIS academic network. And as you can see, UN-GIS is a formal body, which is composed by the delegates of the different member states. And these member states are discussing and making joint decision and setting direction with regard to the production, availability, and application of geospatial information within national, regional, and global policy frameworks. So this is the main commitment of this network of people, which is very relevant for all of us, obviously. And with respect to the UN-GIS, there are also some thematic network, and the thematic network are composed not by the delegate members, the delegate of the different member states, but are, for instance, in my case, members from university. So universities who want to be part of this network, and I speak also for the people online, can apply, can submit their application, and they can become member of the network and contributing with us to all what is needed, as a matter of fact, to the UN-GIS in general. So we are the strategic knowledge and research and training arm of the UN-GIS. And this is the reason also why now we decided to work on GeoAI, because we believe that it is very relevant nowadays. There are also other thematic networks, for instance, the private sector network, and part of the people of the World Geospatial Industry Council are also part of this network. There is also the UN Geospatial Network, and there is also the network of geospatial societies. So if you are interested, you can check on the website, you find all the pieces of information about that. With respect to the UN-GIS academic network, we have an executive committee. I'm the chair of the executive committee. You see here the deputy chair and the secretary. And we have also an advisory board. And those are the people of the advisory board. Probably you know some of them. What I'm presenting to you is something that was born by discussing within the advisory board, and there were many suggestions by those people, so I want to thank them. These are all the members of the academic network. You see, not so many because there are around 70 universities, but they are well spread all around the world. Okay, so what is the reason why we decided to work on geospatial AI? First of all, I have to say that was an exigence coming from us, because as professor of geospatial, we wanted to share with the other people what we are doing with respect to this topic. First of all, I want to start with a general definition, because geo means for us geomatics and Earth observations, including all the possible disciplines that in this geospatial and Earth observation field. So the main problem is that most of us are already teaching something related to geospatial AI, but we don't have a guide because it doesn't exist a syllabus or more syllabi, because we have to decide also if one course is enough or one teaching is enough, or we need more teachings in this field, and it doesn't exist a body of knowledge within this sector. So it is very relevant to define a common language and understanding of key concept, principle, and techniques related to geospatial AI. And in our opinion, this is important for us, but is also important in general because is promoting communication and collaboration among researchers, practitioners, stakeholders, and so on. Our vision is that already our field is very various because there are many different disciplines, starting from geodesy and the photogrammetry, and photogrammetry also the new advancement like drones and so on, coming to GIS, and it's very, very various. And if we add also this aspect related to AI, we have to face these, we have to approach this problem in a very holistic and interdisciplinary approach. So this is another thing that I want to discuss with you. If you agree with us that the best way for approaching it is considering a holistic and interdisciplinary approach. And then obviously, beside all the general questions related to AI and specifically geospatial AI, we have also to understand as professors, as faculty, what we have to teach to the student for developing new techniques, tools, applications, which are not simply AI, because we know it exists AI, but is there something spatial in spatial in such a way that we can start speaking about geo AI and building this geo AI, which doesn't exist at the moment, or is spread here and there, but nobody tried to collect all the different topics. Okay, so this is are the main messages from me. And then I want to comment with you the first results of the survey. Unfortunately, this morning I received some other answers, but I was not able to add in my slide. So it will be a work in progress, but I believe that we can catch the main aspects related to that. So first of all, those are the different countries where are located the universities answering to the survey. Then most of the universities, as you see, are not part of the UN-GIS academic network. It means that there is possibility for them to joining the network. And with respect to the courses, so to the program in which GeoAI teachings are offered, you see that the names are very various, because it is true that we are very various also in the terms that we are using. So geomatics, geospatial engineering, surveying, science, GIS, and so on and so on. So it's not homogeneous, the typology of the universities which answered the questions. And you will see that also in the answers. So with respect to the students who are part of those universities where GeoAI is partially taught, you see that there are undergraduate students, PhD, but most of them are the graduate students. So starting a few people starting from the undergraduate and more people starting at the level of the master. How many hours is taught GeoAI in the university? You see here from this pie that almost 1/4 of the universities answering is teaching geospatial AI for more than 30 hours, which in my opinion is very relevant. So it means that there are people with experience, and if we look on the opposite, there are also 1/4 of university where GeoAI is taught from 1 to 5 hours. So just giving very few ideas about that. And if we look here at the, we asked about theoretical lessons or practice training lab, you see that the percentage of hours is also few hours taught is also increasing. So it means that in some universities they have a very practical approach, giving more hours for training. In some universities they are giving more theoretical lessons, but very few lessons, very few lab with respect to the topic. Okay, but what is interesting is that my colleagues, they believe that it's very relevant, GeoAI. So introducing GeoAI in the university is a very relevant subject. And this is interesting because it means that we need to do something with respect to that. Then I want to show you, unfortunately, the slide is a bit small, but I want to show you some other details. Like the first one is ethics and GeoAI, and the bars that you see are from no relevant to very, very relevant. With respect to these histograms, there are some differences because this one you see is 30 answers. On the opposite, that one is 40. So they are the same, but as you see, in case of ethics and GeoAI is more spread. On the opposite, if we consider all the different, sorry, I have to remove. If we consider all the other questions, so that one, the second one that I'm showing here related to metadata, quality of the data that we have to use, you see that most of people believe that it's very relevant. And if we then go to the details of the different algorithms that can be used, like unsupervised, supervised, or reinforcement learning, it is important or not important. You see that we reach a very large consensus in the last part here of the histogram. And if we speak about machine learning, geospatial application is more or less, the behavior is more or less the same. The same, almost the same is if we consider also deep learning and artificial neural networks. So here we were more focusing on machine learning, here more on deep learning. And you see that is very similar. It is a bit different when we speak about reinforcement learning and application of reinforcement learning, probably due to the fact that less people are familiar with respect to this term. And so that, I mean, the professors are not familiar with this term, and so they don't know what to answer. And also, if I told you that it's very different, the set of the universities and the courses that we approached. And so when we speak about programming languages for AI, you see that we don't reach the maximum here. So it means that not all the universities that submitted the answer are technological universities. Some of them are, some are more, are not technological. And the same more or less with respect to the framework that can be used. But if then we go to more general question like, how much you believe that is important to teach applications of AI in the various domains of geospatial information, which the maximum here that it's available. And sorry, okay. And then the last questions were related, are in some way connected each other, because this one is related to performance and reliability of AI. This is related to uncertainty quantification of AI. And this is related to AI trustworthiness. And you see that they are very similar, and people are interested in, because we have very high bar here, people are interested in this aspect. They believe that is very relevant. Then we have, we had a general question where people were free of adding what it was missing before in the questions before. And you see that some of them proposed something which are details with respect to what was asked before. But I believe that it's really interesting to see that a multidisciplinary collaboration is required. So it is really important for us to have collaboration and possibly multidisciplinary collaboration. It's really an exigence of all of mine, but I agree perfectly with this comment. Okay, if we want to summarize the previous questions, I can say that the aspect that I see, but the aspects that I see, but obviously this is part of the discussion, are that it's very relevant, the Geo AI data. And with respect to that, in my opinion, we can consider what is emerging as data-centric AI, speaking about, in our case, data-centric Geo AI. So what we can propose with respect to that. The second aspect is Geo AI models and algorithms. This is the counterpart of the previous one. And then for sure, the colleagues are interested in Geo AI use cases and applications. The other term that, the other aspects that were mainly ethics and uncertainty and so on, in my opinion, they are very clear. People think that it's very important, but as a scientist, I believe that is not specifically on Geo AI. This is in general for science. So science has to be ethics, in my opinion, and we have to rely with the outcomes of our experiment, our theory, and so on and so on. So it is something that, in my opinion, is already contained in these three elements. But again, this is a part of our discussion. It could be that you believe that we need a specific part of the syllabus that is on that. Okay. And the other, the last two questions are related to the importance of defining a syllabus and a body of knowledge. And you see that there is consensus with respect to that. So it is important to define it. And the last one, unfortunately, I'm not so happy about this answer, but it's good that I needed to show you, because the question was if there are expectations of our students being taught GeoAI. And you see that this is a very various histogram. It's the more various. And then we have also some people say, some colleagues saying, we don't know, we didn't ask. So a good suggestion to all people online is to try to speak more with your students for understanding what are their expectations, because they have the impression about these, at least speaking with my students, they know that this is something relevant, or they feel that this is something relevant. And so I believe that we have to listen to the young generation and try to teach what is useful for them. Okay, those are the university who answered by now. And just for concluding, Andrea already told about that, so I want to show you what is available for the people here, but mainly for the people online. We started this series that is Geospatial AI. As Andrea said, Andrea is the moderator of this series, and this series is created by Nadine Alamé, by Barbara Ryan, and myself. And we organized a lot of events, as a matter of fact. Those are the most recent, as you can see, and some of them are related to say, more theoretical, and some of them are very practical, like, for instance, I organized this training about analyzing Amazon deforestation with machine learning and Google Earth Engine. And it was very, very well attended, I have to say. But the year before, I organized also a workshop about satellite data analysis, machine learning classification with QGIS. And this was probably the most attended one. More than 1,000 people attended it. So there is an interest with respect to that. There is an interest with respect to the theoretical approach, but also training. So learning how to work with the tools in a very starting from the easiest way, because you see this one, QGIS, means that is very basic one. Google Earth Engine is a bit more complicated, but there is an interest by general interest with respect to that. Okay, so this concludes my short introduction, and I want to thank everyone. So the advisory board member of UN-GIS, the participants, the ITU staff, and you for being here. Okay, thank you. Okay, so at this point, we were supposed to have Alex, but Alex is not here, unfortunately. But I see that Guillaume is here. So Guillaume, do you want to say something as a UN Geospatial network with respect to Geospatial AI?
But online, I don't know if people can hear me online. Hopefully somebody can notify. For the room, it should be hopefully okay. It's okay. Who's monitoring online? Yeah, they can hear. Okay. Oh, very good. So Alex, then perfect. Better that way.
So in the end, we have Alex. So Alex, are you there? Alex?
It's lost. It's not connected.
Is it the right balance? I guess I'll mention a few words. I want to thank Maria Brovelli and Andrea for leading this Geo AI workshop, and previously also all the events and learning contents that you have provided. Today we're very fortunate to have both the chair of the UN-GGIM academic network and also Céline, who's here representing the chair of the UN-GGIM Geospatial Societies. And I see, of course, Andrea, and maybe there's other colleagues from the United Nations family, and I'm the secretariat for the UN Geospatial Network. So there is quite a few networks that are represented here, all from the UN-GGIM. But I think there is really an interest to bridge, as presented by Maria, the different components which are interested in AI and geospatial information, whether it's Earth observation, geography, and et cetera, and the different components, and how to bring all those things into a meaningful curriculum. Certainly, the UN is interested in probably the later part of what Maria was mentioning on use cases. The UN Geospatial Network as a whole is really interested in leveraging some of the data, models, training content that the academic network or the geospatial societies can provide. The UN is, of course, more interested in using this and not necessarily only the pure research and training. But certainly we look forward to hearing all the good recommendations on good syllabus that can be put into place under this overall umbrella of Geo AI, and how it can contribute meaningfully to the colleagues in the UN who are already using all the remote sensing and images that some of you are providing, or tools that you're providing. Also, we have representative from the UN Geospatial, the private sector network. So I think it is really important to bring all those people together and try to move forward on those advancement of technologies, models, etc. All together. So thank you very much again for your leadership, Andrea and Maria, and thank you for bringing us together.
Okay, so thank you. Yeah, I have to say that, yeah, you are interested in application, but UN in general has also a lot of data, which can be very interesting for AI. So that is another point. Like, for instance, FAO, I know that they have plenty of data, and many of them are very useful. So thank you also for that. Okay, so the next speaker is not here, or the next two speakers are not here. The next speaker is Paloma Meredio, who is the chair of the Bureau of UN-GGIM. And as she was not able also of attending online for some private reasons, she sent us a video. So we will show the video of Paloma.
Additional pressure on existing analysis tools. Reason why one of Currently, the repository of geospatial data is increasing every day, putting additional pressure on existing analysis tools. Reason why one of the main challenges related to geospatial data is its management, resulting in a need to explore the inclusion of novel methods for the integration, transformation, and analysis of geospatial databases from multiple sources. In this sense, geospatial AI constitutes an alternative to improve the provision, efficiency, and value of existing geospatial processes, products, and services through a variety of techniques, tools, and applications. There are approaches used to treat geospatial data. A current trend in geospatial data, including from Earth observations and citizen science, is to apply machine learning methods and compare the results obtained with the traditional data. Natural language processing and computational learning provides the opportunity to analyze large amounts of data. In addition, these strategies are particularly attractive since they broaden the lens of analysis, allowing the multidisciplinary nature of the field to which they are applied to be explored, as well as interdisciplinary approaches. In this sense, although traditional methodologies make it possible to measure and monitor a wide range of issues related to sustainable development, these new techniques aim to make the analysis of large amounts of data more efficient. This rapid development of geospatial science and artificial intelligence has led to geospatial AI become an important technique for geospatial big data analysis. For this reason, in the public sector in Mexico, there is a growing interest in the application of artificial intelligence, especially machine learning, for the generation of official statistical and geospatial data, because they can help address the cost barrier and will allow national mapping agencies to provide timely data for users. At INEGI, AI methodologies are being experimentally implemented that provide the possibility of producing solid and adequate data to be integrated into the main national and international initiatives, such as support for the Sustainable Development Goals, with the purpose of subsequently integrating geospatial AI in the generation of official data through concrete and formal information products with a long-term perspective. In addition, INEGI's increased interest in the statistical analysis of satellite data to produce measurements of the environment, agriculture, and sustainable development is causing a growing interaction between earth science and statistical domains, such as machine learning. There is also a growing interest in the use of satellite imagery and other big data sources to examine the relationship between environmental and socioeconomic indicators, such as poverty. This interest in measuring natural resources and official statistics from freely available big data sources has led to the initiation of a link between the statistical and remote sensing disciplines. As a result, applications of computer learning algorithms are being developed to answer questions related to these topics. At INEGI, projects have been developed that use alternative sources for AI to generate experimental statistics, such as, first, the Geospatial Data Cube of Mexico, which is a technological platform that allows access, processing, and analysis of large amounts of data. On the other hand, the Data Cube platform guarantees intelligent handling of satellite data that optimizes computing resources and capabilities. On the other, with its interface, the end user can retrieve images in a format ready for analysis. These capabilities make it possible to take advantage of satellite imagery to generate information in a timely manner. A second project is a geomedian generation. The cube facilitates the generation of composite mosaics, which take advantage of the information from all the images of the specific period, such is the case of the geomedian mosaic. This is very useful to perform a multivariate statistical summary of all the observed values of the same pixel in an indicated period. The data cube allows the implementation of an algorithm that produces an image composed of summary of pixels of a specific region in a determined time. A third program is measuring the state of mind of tweeters. This project has managed to specify an application to determine the scope of subjective well-being using non-traditional sources of data such as social networks. The application automatically qualifies each tweet according to the emotional charge that identifies the state of mind that the tweeter had when she wrote the tweet. This provides information on well-being of Twitter users. And finally, the DENUE with a gender perspective. This is a model to automatically identify and classify services that provide support to women with a geospatial approach, with the aim of contributing to closing the gender gap in terms of accessibility to services with a gender perspective. The model has been developed by taking advantage of natural language processing and computational learning methods applied to the information of the economic units contained in the National Statistical Directory of Economic Units, the NUE. In this sense, the growing adoption of geospatial AI as an important technique for the analysis of geospatial macrodata in national statistical and mapping agencies generates the need to have people trained in the area, from the understanding of the fundamentals and the state of the art. Therefore, to highlight the importance of geospatial AI within institutions, it is necessary to define training programs on the subject, with the vision that in the future, geospatial AI must be carried out efficiently and used in response to meaningful demand, the ability to use data for public policy purposes, and as tools to provide social change. In other words, the appearance and importance of geospatial AI puts into the picture the importance of educating in a more structured way the new generation in this field. In this sense, the new curricula should seek a multidisciplinary approach that allows not only understanding the fundamentals and the state-of-the-art of GeoAI technologies, but also the management of new geospatial and artificial intelligence techniques, tools, and applications. On the other hand, although geospatial AI represents a significant potential in the production of geospatial data, integrating it into official data production processes implies several methodological and regulatory challenges, mainly in terms of data reliability and quality. In that sense, quality assurance is our main concern related to the data produced by AI, followed by reliability and the existence of a verification and validation process. In the case of INEGI, as a national mapping agency and statistical office, we have the responsibility to provide data of absolute quality and veracity. Thus, the next step should be aimed at developing frameworks and methods that allow the verification of the quality in the information. Looking ahead, geospatial AI will be in the center of our work and will allow us to contribute to sustainable development by providing reliable, timely information. Thank you.
Okay, so thank you. Unfortunately, we don't have here Paloma, but I believe that she's representing, well representing very advanced people of the government who have in mind how to use geospatial AI and their importance. And but now we have we want to show you also another survey, and on the opposite is the survey that was sent by Lokedra, was created by Lokedra, who is online because he was not able to obtain the visa for coming here, and so he is not here. But Lokedra is online, I'm pretty sure, because I'm seeing him. Okay, so good morning, Lokedra. Good morning, and thank you for being here. So you, do you want first of all to quickly introduce you and then to show the result of the survey to the private sector?
Sure. So, hi everyone, I'm Lokedra Chauhan. I run a small startup based in Minnesota, which focuses on geospatial AI, and I've been, I'm glad that Maria and Barbara, etc., decided to ask me to host a survey, create and host the survey for private sector to represent what the private sector wants in terms of like what are the needs of private sector for GeoAI skills from the people, at least the fresh graduates which are getting hired from the university, and otherwise also what are other kind of training needs they might have, because a lot of them do consider upskilling as a big, it's like you already have people, and if you can train them, that's always best. So those are the two aspects which are there, and I'll show you. Let me just put my screen up. So So I'll just give you an overview from the private sector side, and then we'll talk a little bit about the technology, geospatial AI in general, whatever little I understand of it, and then show you the survey results. We'll try to keep it brief, but let's just go. That's a sec. Yeah, hi. So first things first, what is GeoAI? Or basically, in fact, Stephen in the crowd there, he has suggested that I must start with a definition of GeoAI. So the definition we use is basically, the GeoAI is an amalgamation of AI and spatial computing to develop a better understanding of the physical world around us. And that's at the level of individual, communities, cities, nations, or planet, using the geospatial data. And that's this is the definition we use in the GeoAI report, which I had written for WGIC earlier. Now, what do you mean by geospatial data? I think the crowd here probably understands this much better than me, but still, we have different kind of sources, and I've just listed these sources here. We have sources both like above and below ground and on ground. As they say, everything happens somewhere, and almost 80% of the data is geospatial by the virtue of being, if you tag it to the location component. So that's what we're looking at. Now, what makes geospatial different? And I just wanted to add this bit a little bit here. And there are two main things. There are a lot of things which can make geospatial data different, the way it has to be treated, etc. But from the perspective of geospatial AI, or the modeling part, the two important things are like, first one is spatial autocorrelation, and it's important. It's based on the Tobler's first law of geography, that nearby things are more related than faraway things. And basically, you see a continuity in anything which has location attached to it, whether that's language, whether that's weather or soil, water. And that, so that's what it is. But then what it means for analysis is that it violates the independent and identically distributed data assumption, which most AI or machine learning algorithms make. Hence, the geospatial data needs to be treated differently. Another aspect is spatial heterogeneity, and this is also important from the analytical perspective because, so basically what it means is that the geographic attributes vary, the distribution of geographic attributes is very uneven, and across the landscape, again, could be whether you're talking about terrain formations or the kind of species we see around the globe, or cultural attributes, etc. So basically, in one word, we could say that there's no average location that can characterize the Earth's surface. And it ends up making the data non-Gaussian. And that's where we have to be careful in terms of when we're trying to analyze, or we want to make sure that heterogeneity gets reflected in our analysis properly, then we have to treat accordingly. So those are the two key things which make geospatial different. And just to make the same point again, I'll just ask a small question. So what do you guys see in these pictures? Now, I'm just going to assume that most of common answer would be that you see snow. But as soon as I provide you a location where these pictures are taken, your answers are going to change. And it's like, now you can probably clearly say that one is snow, another is salt, and another is white sands. And this is why, this is how, this is to just signify the diversity of, or the spatial heterogeneity point, that we need, the computer vision algorithms can be fooled very easily if you don't take into account these location perspective or the geospatial perspective into our AI algorithms. And that's just to make the point. Now, in fact, another kind of data which people in geospatial world use quite often is using the whole spectrum, not just the visible spectrum. And let's say if you had infrared imagery, then also you could answer at least differentiate between snow and not snow easily. So that's just to make it the point that why we need to treat geospatial data differently. Now, so right now, I'm sure like most of you being academics, etc., would be aware that, okay, we have had the traditional data science algorithms or methods, and then there are corresponding methods to deal with spatial autocorrelation or spatial heterogeneity. But the next phase, which is going to be very important, especially like, okay, now that everybody is talking about ChatGPT, so this is like the next phase for both AI and GeoAI is going to be the multimodal, or which is where the convergence is also going to happen, is that we're going to get into multimodal GeoAI foundation models, which could answer spatiotemporal and retrieval queries in natural language. And that's going to change a lot of these things. It's just like a lot of analysis is not going to happen the way or we see it, or maybe more of that will happen, but then a lot more of natural language queries will happen when we are able to enable everyone to be able to make such queries. I just wanted to give quickly like 2 examples of the projects I have been working on. So one is on, we are working with some researchers from University of Minnesota and the sustainable aviation fuel company called Clean Joule. They like we're developing a multimodal foundation model to be able to answer the questions like where should they grow the best feedstock crops for the sustainable aviation fuel they want to produce. So, which is like they're looking for camelina and carinata, the 2 specific crops. So, what are the ideal locations where it makes the best sense, both in terms of economics and for environmental benefits? Similarly, how do you manage those crops, or how do you measure and verify the carbon across the value chain? And these are like, and we are trying to use both, not just all kinds of data, but there's a lot of know-how already existing in terms of agri-science models. So how do you build models which could actually take advantage of the existing know-how of people in agri-sciences? Similarly, this is another project we are doing with the Indian government, where Indian government has a national data access program where they're trying to put all the public data into one place, and idea is to be able to allow anyone and everyone to query those data sets in natural language. Now, obviously, it requires how do you make the model learn spatial or spatiotemporal sense? So that's one of the key things. But then, yeah, right now we are starting with, and on the other end, we also want to be able to make sure that how do text queries of people get converted into SQL queries. So right now, the focus is on the structured data, and then we get into integrating into other foundation models, especially for remote sensing data. And I guess Andrew is there, where like Planet, his company has been working on, has some great work on foundational models for remote sensing data, which allows people to query. He can tell much more about what they are doing. But yeah, idea is to be able to integrate with other models so that we can, not just we can, the government can actually provide people access, people, especially bureaucrats, access to all kinds of queries. Now, here's another aspect which is important, which we need to keep in mind, which is like, traditionally these are the kind of users we see, or in fact, in the early ages, it was mostly experts, but then slowly another layer of analysts got added. And then we have individuals also who actually use geospatial AI or geospatial services often. Now, it's just like when we have these GeoAI foundation models, which will allow anyone to make queries in natural language, then what kind of curriculums would be required? I think that's another, this is like, we need to be able to thinking about the curriculum or the topic, which is the topic of this event, in terms of like, what are the needs of different categories of users? And I think that's the only point I wanted to make here. Now, so I'll just show you the results of the survey which we conducted, and is still being conducted. So if any of you wants to respond to it or want to share it and get more responses, that would be really great. Here are some of the here are the findings as of now. So in terms of geographical representation, we got 24 countries represented by the respondents. And I think that's really great because even though most of the responses are like one responses from each country, and US and India kind of dominated a lot, and UK also had enough. And this is like 24 countries getting represented from 42 responses. So we definitely want more responses. But, in terms of association memberships, because that's something which we wanted to know, like where people are coming from. So UN-GIS private sector network, which I am also, my company is also part of. We so there, like we got the highest responses, 21. Similarly, OGC had 11 responses, WGIC has 6 responses, and then there were others which were not affiliated with any of these agencies. And just wanted to remind that there are some of the overlaps, that entities which are part of multiple groups too. Now, in terms of when we ask like how confident people are about their AI capabilities, there's 31% of the companies or respondents said that they are quite confident. But that's 69% of the respondents were not confident and said that they lack GeoAI talent, and I'm not sure like how exactly they are going to be able to manage that issue. But then when we ask like what in terms of like how do they plan to respond to this, 62% of the respondents said that they're focusing much more on upskilling employees, and 38% were not thinking of upskilling, but they said they want to hire, but they find it very hard to hire good talent for GeoAI specifically. Now, I think it's an important question which to help the people here, especially the academics, that okay, when we're looking at recent graduates, it's sometimes harder to find the right talent, and then a large number of people are looking at upskilling employees. So that could be it could be different kind of coursework which is required, syllabus which is required to be developed for them. Do university graduates have required skills for GeoAI jobs? Now, this is a question which Maria said that we must ask, and I'm glad that we did, because there's almost like 2/3 of the people have said that they don't think that the current graduates have the required skill sets which they need for the GeoAI projects they have usually. But then there are 31% who said that the graduates are good enough to get started on their jobs. But yeah, this is just because there are a lot of academics in the room, I would say that this is something which you should consider. Another thing which I'd asked was, like, because a lot of people are coming from either geometrics or GIS background, or some a lot come from computer science background and then try to learn the other side of the technology. And here, interestingly, the response has been like, since I got the first 4 responses, since then it has been even to the middle. It's like almost every time one response you get that, yeah, people would prefer computer science degrees. The other response you get is that people would prefer geometrics or GIS related degrees, geography. Yeah. So I don't know what, I think you guys can make better sense of it, but yeah, this is what the industry thinks. Here, like, we ask them for specific skill sets, and I think those get divided broadly in terms of the foundational software development related skills like programming, etc. Then how do you deal with geospatial data, mostly around GIS and visualization, etc. And then machine learning or AI related skills like the data engineering or MLOps, etc. So that's but this is the broad distribution, and I'm sure I can share the exact I'll be sharing the exact data with Maria, so obviously you guys can use it much better to define these things. Now, here's like some of the other questions I tried to summarize here, like this. So there was almost unanimous agreement on the kind of AI and geo skills that are required, both foundational and analytical skills. And yeah, some of those I mentioned in the earlier list, and then I can share further. I'm like, yeah, later we can, I'll share the detailed data with them. So it's broadly those things. And then I have another slide, which is outlining some of those as a summary. And then another thing which did come up, and I think it's quite relevant, is almost all the respondents felt that keeping up with scientific and technology advances, especially in GeoAI research, is very important, critical. They came out with a lot of different kind of suggestions on how it should be tackled. A resounding yes was to have something like a GeoAI hub for all GeoAI research on new tech advances being showcased, so that people don't have to go to different places and try to identify themselves. It's like well-curated list. There were other suggestions around, yeah, in fact, a lot of suggestions were around using e-learning as a method, like basically more of e-learning resources, not just classroom resources. And I think that's also an input you guys would appreciate. In fact, in some cases, people also wanted to understand that, okay, how we can use it more like just-in-time training. And I think from an industry perspective, when I get a project and I have a problem and okay, I need to know how to solve this, I immediately want to learn how do I use this kind of data, or what kind of method do you use. So it's like the just-in-time learning is another way in which people in the industry definitely look at solving problems. And I guess academics could keep thinking, could keep that in mind. Then there were other suggestions around like how do you use social media ways for such kind of knowledge management, because community can contribute together. But yeah, it broadly comes in line with the GeoAI hub idea, which is something which we should be considering anyway. Here's my understanding of the skills and competencies required based on the other details which people provided in some of the open-ended questions, etc. Now, as Maria had already covered, so like, okay, ethics and safety considerations are very important, and this is where, so these are like more of the foundational skills. So that, so here, like being able to understand the kind of biases you can see in geographical data, specifically, like mostly you'll see a lot more data from developed countries versus developing countries would have a lot less data. So like those kind of issues. Similarly, data privacy related issues are there. Then other kind of skills which people definitely have said yes is about standard computational skills. Basically, anyone should be having if you want to be able to build models or build software systems. So that's there, like Python and JavaScript, etc. Now, getting a little bit more into the category wise. Okay, so from geospatial science, mostly people want their candidates to, or at least employees to know, how do you deal with spatial data, ideas like spatial databases, or how do you work with remote sensing data, which is one of the biggest and the most fastest growing kind of data which is available. And yeah, a lot of work is also happening on the point cloud data from LiDAR Census. So that's one kind of skill set people want. Another from machine learning. Obviously, they came up with specific methods, etc. And switch from deep learning to, and yeah, there were a significant number of people who also wanted to go in terms of how do you go about graph-based analysis. So let's say graph neural networks, etc. And obviously, you want the strong mathematical foundations. The third was, yeah, like it's a little bit of my contribution also, which is like in terms of domain knowledge, because geospatial problems are often multidisciplinary, as you all know. So you need understanding of the geospatial science and AI also, but then at the same time, domain knowledge comes into play, and that's quite important. So let's say when I was talking about the agriculture problem, so that's how do you integrate the domain knowledge?
Lukenda, we need to stop you. because
Sure.
we have
I'll
also the other people who want to speak. So go to the conclusion very quickly. Thank you, and sorry.
No, so sorry, that's fine. Yeah. So, so in terms of how do you integrate domain knowledge into the into this problem-solving process, and I think there are different ways to do it, whether at the data stage, model architecture stage, or how do you design loss functions. So that's it. And this was my last slide anyway. Thank you so much. Sorry.
Thank you very much, Lokedra.
Yeah.
Now I will give the floor to Alexandre, who has just joined us from Nairobi. If you can make it short, because we are running a little bit short of time. I thank you very much, Alex. The floor is yours. Hello, Alex. Alex, are you hearing us? Okay, yes. But we cannot hear you, eh?
Can you hear me now?
Yes. Thank you.
Okay. Let me, well, first and foremost, my sincere apologies to the Geo AI conference and UF for good colleagues, particularly to you, Andrea, ITU, and Maria, and the academic network for unforeseen circumstances. I was not able to join you in person, so I was supposed to be there. That's my first apologies, and congratulations on the event, and my deepest regards to the participants in this important conference. Let me give you just I'll be very brief, because the important thing here is to communicate that within the UN-GIS and the Global Geospatial Information Management, we do have the UN Geospatial Network that is responsible for strengthening the coherence and coordination of geospatial management across the UN system. So to get an idea, it's very fragmented, as we know, the whole UN system. And so in order to strengthen coordination of the UN system itself, we created in 2017 this network that puts together now 40 UN agencies, funds, and programs. You have here an idea of the richness and the depth of the network by represented on, as I was saying, the 40 agencies and the 5 pillars of the UN. You can see there agencies that work on peace and security. You see the agencies that work on sustainable development, agencies that work on humanitarian action, some on international rule of law, and finally, last but not least, human rights. So the importance and why we intend to strengthen the key message is how we can use geospatial, how we can use AI on top of these asset, which is working as one, as a network. We created for this purpose the initiative of the One UN Situation Room, which brings together to a data hub platform the assets of geospatial from the 40 agencies. The One UN Geospatial Situation Room was launched and approved, endorsed, and noted by member states in August last year to 2022. And this year in Nairobi, just last month, on the 15th of June, we had the opportunity to launch this data hub as a One UN data hub for geospatial information. The good thing about that, and that is presented in this slide, we kick-started by presenting 7 pillars or 7 data streams that go from, and we have ITU there, from the infrastructure and digital infrastructure of the world with a layer of geospatial information provided by ITU, led by ITU, this pillar. But you can see information then on humanitarian, such as the Refugee Migrants Index that is provided by the UNHCR, but also the International Organization for Migration. Or you can look at land cover, land use, very known asset of geospatial from FAO, or an environmental data information from a UNEP or WMO on environmental data and climate change data. The power of using this approach is that we can have one map as a base layer. This map is the recognized UN map. We're at the admin level 0, 1, and 2 for the base layer. And then on top of that, you can have all these rich geospatial information managed independently, autonomously by different agencies, but that come together to a single one data hub. My proposal, and that's, of course, you can have a different perspective on these, such as looking at the different data teams, the geospatial data teams provided for the whole 193 member states on geospatial information management, GGIM, and you can see how the interlayers of data, socioeconomic, refugee data, environmental data, communication infrastructure, health data, educational, land cover, and Earth observation data. So the perspective is in 1 to 2 years' time, we will have a tremendous variety and volume of data that can be used across the UN, but for member states and worldwide. My challenge, and that's the contribution I'd like to give to the GeoAI Summit, is the following. A powerful toolbox like artificial intelligence can be used on top of this data to actually extract very rich information and to make sure that we have applied information and use cases that benefit the best from this tool. So the key message is, now that we have a one data hub for geospatial information across the UN system, let's use it and let's build intelligent, let's call it intelligent, artificial intelligent use cases that can benefit the whole world on using these. This slide presents how we are going to put this together, not only as a data hub, but how we intend to use foresight and scenarios on use cases, such as, for instance, disaster and education threats, such as the operational crisis management, logistic analysis, or even as I brought the case of ITU, the digital connectivity and digital economy. So the message I will bring to the summit is the following. The problem no longer being to have a data hub, one UN situation room where we can have access to the data layers, geospatial data layers, how we could harness the power of artificial intelligence on top of this data hub to actually make good use of it for the UN system, and of course for member states and for the good example is now that we have this is up and running on the one UN geospatial situation room, information on universal connectivity and digital economy, whether this is led by ITU, GDP agriculture estimates provided by the World Bank, or humanitarian data on migration provided by International Organization for Migration, how we can make best use of the toolbox of artificial intelligence to actually extract knowledge for action on top of this one UN geospatial situation room. The final message is the one on behalf of the 40 entities of the geospatial network. We'll be very much interested in furthering this discussion with the ITU, with the academic network, with all the colleagues that are participating in this great Geo Summit, in order that we could explore to the maximum how artificial intelligence toolbox could be used on top of the one UN situation room to deliver value for humanity, basically. Let me just finalize by saying that we are aware of the various issues that geospatial can bring and the complexity. You will be discussing some of these issues, such as governance, outreach, communication, capacity development, partnerships, the technology itself, and of course, data standards. And I think the same that we apply in the same framework for the One UN situation room. I believe that if we include an artificial intelligence layer on top of these, then the same kind of dimensions will still apply. So we have to look at the challenge that all these different dimensions will put forward. I wish you all, again, sorry for not being present in person there in this big summit. Wish you all the best. As a follow-up action, I would very much like to have ideas, to have a proposal of activities in partnership that the One UN situation room could be using artificial intelligence for extracting knowledge from these huge data bank that will be available, is starting now to be available. And in the coming 2 years, I expect to have more than 1,000 geospatial layers available from all the corners of the UN system. A big thank you, and I wish you all a fantastic summit. Again, looking forward for the forthcoming actions of collaboration that we can do together. And once again, thank you, and wish you the best for the work there.
So thank you, Alex. Very happy to have you at least online. And yeah, we are missing you, but you stay here with us. Okay, thank you, thank you. And
Thank you, apologies.
now, after the university and UN, because the order was university and then UN-GIS and the UN Geospatial Network, and then we started with the private sector. So the Lokedra presentation of the survey was for anticipating the discussion of the presentation, the panel of the private sector, which will be moderated by Stephen. So, Steve, I give you the word now.
What kind I need to finish?
Now you have 25 minutes and then 5 minutes of summary.
Okay, whiz bang tour from the private sector. Okay, hi everybody. Sorry, my back, guys. Stephen Ramage from rezoconsulting.com, small geospatial advisory firm here in Geneva. You've seen everyone. If you haven't, it's on the website. Everyone's bio is on there, so we have a short amount of time. So I'm just going to introduce everyone by their name and let them speak. All you need to know is they're all very experienced and senior leaders in their organizations and in the field. So I'm going to start with, maybe before I introduce Frank, I'll say that as well as being senior leaders in the field, they've also worked with research and academia in different ways across each of the organizations. So they'll give a little bit of insight into what they've done there. And then I guess talk about industry expectations around geospatial AI skills and experience. So building on everything you've heard. So I'll go to Frank de Morcier, who's from Picterra. We'll start with you, Frank.
Thanks, Stephen. I hope everyone can hear me properly. So I'm Frank de Morcier, one of the co-founders of Picterra. So Picterra is a Swiss-based company. And at Picterra, so what we are doing is really trying to bring machine learning, let's say, out of the typical field of machine learning practitioners. So to bring that really into the more the analysts that we saw, the geospatial, the GIS people. And so is taking the form of a platform where people can create machine learning model, apply them on imagery to extract information. And so that's one side of what I'm doing. And then I have a background where I did a machine learning a PhD on Earth observation data at the PFL here. And I also kept a bit of teaching. So I've been giving classes on Earth observation, image processing, machine learning in different universities around here. And I think it's interesting to look a bit at what we have ahead and the future. So all this, where things are going and where maybe there's this gap of the next generation we are preparing. And there was one thing that Stephen actually pointed me out just before, and that we saw in one of the survey. There was this thing where one of the most important skill was about programming, and the less relevant skill was about coding. And I think that's quite telling something. So there's really this foundation where we know that everyone needs now to have an understanding on coding, needs to have an understanding of what's behind this machine learning algorithm, and still be able to understand something when they see a code. But we are getting a bit away of people will have to recode models. Now models, foundational models are coming into play, and that's what we should really expect. So it will be less about really crafting coding, but having this general understanding, I believe. So meaning that's where the multidisciplinary approach will be needed. So people will have to be generalists in that sense. They will have to have the understanding of the limitations, but we should not expect that they will have to be able to recode all these models. So I think that's really, we have to be careful there. Where is a bit the limit? The risk is otherwise we end up with a curriculum that is too vast and impossible to tackle. And I've seen that in one of the classes I've been given. 10 years ago, people were discovering machine learning in that class. So it was mainly engineering students, but on the environment side of things. And nowadays they all have machine learning classes on the side. And so in that courses, we are more focusing on the applications and what model, what limitation do you do? What model do you use? What are the limitations for that in that application? So I think the next challenge is mainly about being all conscious of the application, the use case we need to solve. And that's what has to be also taught in these curriculums. And having the capacity to put the right, let's say, technology, the right models in front of that. And then hopefully we hope the people like on my left bring the data, the analyst-ready data, so that this can be a little bit left on the side, and that we can probably spend a bit less time on the curriculum to be really dealing on this preparation of the data and all that. So if you take it from analyst-ready data, data cubes, then we can be more focused, let's say, on the application.
Perfect. Merci bien. Our next speaker is Tegan Jian from SI Analytics, who's possibly the furthest traveled here from our panel.
Yeah. Good afternoon. This is Tegan Jian. I'm the founder and CEO of SI Analytics, and we are GeoAI company, and we have no experience for the geospatial domain. I just have the strong experience by the AI technology. So naturally, we have to make our own curriculum for training our own members. So based on our coaching experience, the theoretical part, as already mentioned, for the geoscience and AI and domain knowledge is really important. But the most important thing is to meet the real use cases by ourselves. The experience is really important. So, but at that point, the challenging part is to deal with the very large scale satellite data and or the data handling or the control all the GPU infrastructure and the coding and programming AI program by themselves. And all the challenging is the struggle point to teaching and coaching or the delivering the knowledge from the teacher to the student. And recently we built this whole teaching environment in the cloud. And we nowadays, we provide our teaching environment for the most top 10 university in the South Korea. And also we provide all the space industry company members in the South Korea. And we regularly teaching them, especially the satellite manufacturer or the GIS Research Institute. And also 2 years ago, we started the UN-GIS space international program. And we teaching the worldwide, the most 10 countries, the high school student to experience the real situations, how they can deal with the satellite imagery and how they can extract the real value of the geospatial data using the artificial intelligence. And the most important thing is how they can meet the real cases by themselves. And we are strongly continuously work with our technology, and we can show all the value and how easily they can meet the real world cases. And we have a plan for expand our capability to provide and process and how they can easily meet their problems and by their domain knowledge. So we continuously provide our customer or the most important research partners in the Asia country, and also they can make themselves much wiser or the much deeper knowledge by themselves, and they can understand the importance of the GeoAI technology or the natural important point of view of the geospatial AI. Yeah, thank you.
Thank you, Tegan. Daria Lutker from WeGo. Daria, sure. Yeah.
Don't know how much that helps, but we can try. So yeah, my name is Daria. I'm the CEO of WeGo, and I represent, I think, a little bit more the startup and SME perspective on this. So maybe a little bit about the background of the company to know where I'm coming from here. We create digital twins for snow and water for the energy industry. So we use geospatial data and AI, and we create these digital twins to have an overview how much water and snow is available, for example, for hydropower, to help them generate and trade more sustainably. On the topic of AI, so just a little bit of where we currently stand. We have worked both with deep learning and with traditional machine learning. And some applications that we have is, for example, cloud cover removal, spatial interpolation of in situ data. We work with historical simulations of our geospatial variables, and that's just a little overview. And on the current connection that we have with academia, for us, there are, well, two facets to this. One is we work with kind of scientific advisors. So here in Switzerland, we work with the SLF because it's always good to get this like very high expertise input on what we do, even though, of course, the standards can't always be applied. So academic research has much higher standards than what is necessary in industry to have a potential impact on the commercial side. Just good to remember. And on the other hand, we work with students. So we work with University College London and with Imperial, and we just had some conversations with Polimi, actually, to have master student projects within the company. This has been really great for us. So mostly there are spatial data scientists with a background in spatial data and AI, and have done things such as glacier extent tracking or commodity trading and the impact that snow and water have there. But there are, of course, very specific challenges that come with this. And one of the most important things for us is the issue of like IP. So since we are a AI-based and, well, software as a service company, the algorithms are what makes the company and where we can create the value. And having student interns that, of course, want to publish their hard work, and the professors that we work with, it can be very difficult to have them work at the actually important things, because we cannot let them access the heart of our system because it has to be published. So that's, for example, one of the main issues that we are facing is there is no real standard on intellectual property and commercialization. So that's just something to like throw in here in case someone wants to discuss this later. And picking up a little bit on the basic standards that we definitely need to work with these students, also to hire people. It is, I would say, an understanding of the frameworks. We work in Python, as many small companies do, because it's open source. A lot of businesses depend on open source data. For example, Matplot is not really what we can do, what we can work with, because it's commercial. So having an understanding of these Python frameworks, NumPy, GeoPandas, in addition to geospatial knowledge, such as coordinate reference systems and some basic information, of course, on machine learning and deep learning, would be very helpful for us to have, like, I would say, meaningful work done quite easily, because as we saw, there's like a 50-50 split. What's more important, computer knowledge or IT knowledge and geospatial knowledge? It is hard to teach either way. And especially for small companies like ours, where when we need someone, we need them, and we would need them to have an impact quite soon. Long training periods and teaching all the basics is very detrimental for small businesses because we just don't have that much time. So, yeah.
Thank you. Thanks, Sean. Okay, last but certainly not least, Andrew Zolli from Planet.
Hey, everybody. First of all, I just want to congratulate everyone for their ability to sit quietly and absorb information for this is like the 14th hour of this session that we're listening to all this material, and we've only got 9 more surveys to go through, which I'm really excited about. I'm the I'm what's called the Chief Impact Officer at an organization called Planet. Some of you may know us. We operate the largest constellation of Earth observing satellites. We collectively image the entire terrestrial landmass and near oceans of the Earth every day. I oversee all the work we do in climate, sustainable development, humanitarian, human rights, and a whole bunch of other related fields. So all of this work is extraordinarily important. Maria, we are deeply in need of a pipeline of extraordinary talent to meet this moment. And tomorrow I'm going to give a plenary talk about this, so I'm not going to preview those remarks too much, but I do want to just pick a couple of things out. So the first thing is, do we need a syllabus? It is incontroversial that we need a syllabus. The question is, who are we training and for what purpose? We absolutely need to advance the intersectional science that sits on the 3 pillars that Lokedra showed us, which is that multidisciplinary intersection of machine learning, geospatial data, and the 3rd pillar, which is about climate, sustainable development, the key challenges that the UN ecosystem and family of institutions like forced migration, water, we could go on and on and on. Right? Those are unicorn people, and you need to be in the unicorn production business, right? We need to understand where we can cohere no fields. But I don't think this is really just, and that work will continue for sure, because it's the work of scientists and academics to do that work. I think the thing that's really important that I want to contribute to your discussion is that it feels like the library science era of geospatial is over or about to end. And for a couple of reasons. So the way that I think about it is it actually kind of breaks into 2 different pieces. One is the continued difficult, rigorous, exacting, peer review worthy production of derivative knowledge assets that tell us where in the world all the water, carbon, sustainable development, emissions, fill in the blank, all of those things around the world. And the world, as Lokedra mentioned, is not homogeneous. There is no average place, so it's going to mean very different things in different places. That work, which is going to require tons of ground truth data, it's going to require all kinds of basic epistemological questions and methodological questions, is going to be in front of us for a long time. But then there's this other fork, and that other fork is the marrying of those assets to new kinds of large models that allow us to do things like query them, ask them questions, and to potentially get predictions, because the difference between producing a result from a large multimodal model and predicting is fairly narrow, and we're seeing really interesting work there. So there's a whole new genre of work to be done there. But I think the most important thing is about who gets to participate, because what we're describing here, I mean, I think about it like this, like I'm not here advocating for the private sector in any way. We deeply interoperate with and are only capable of existing because of the work that's done in academia. So I don't want to, like, this is not about putting, the private sector on some high horse, but I think about this question of like, what made Google Google? Okay, the first thing they did was they came up with a novel way to index the internet. And if that's all they did, then if you wanted to find out what was on the internet, you would go to somebody and say, you got a PhD in how to access that index and like code for it and build things around it. Can you help me get access to it? And that is exactly where geospatial is today. It's exactly the same space. It's like we say, hey, we've got this bright shiny thing. It looks like a car. Would you like to buy it? And then when the person comes in, we say, here's a plan for a car and 4 wheels and a wrench, and you have to hire a mechanic. Okay, so that era, right? The second thing that Google did was they put the world's most sophisticated index of the internet behind the world's easiest to use user interface, where you could just bang on it for a long time until you got the answer that was sort of approximated what you were looking for. The interesting thing is everybody talks about capacity development for geospatial data and AI. Nobody talks about capacity development for the search bar, because everybody knows how to use the search bar, right? So you either solve the capacity problem on the interface side or on the index side. The third thing that Google did was they built an economic model where they sold ads in between the two, and they just ruined newspapers and like lots of other things. That's terrible. And they became a bajillion-dollar company. But we are at that moment in the next 24 months, guaranteed, I would stake money on it, that we are in a moment when we are going to start to see the integration of geospatial data that is delivered into answers where the person who gets the answer never sees a pixel, doesn't care about the histogram, doesn't care about the number of standard deviations in the plot, but gets a plain English answer to a plain English question. And all I want to say to you is that you have to prepare to do 2 things in your syllabus, at least, which is you have to train the next generation of scientists and multidisciplinary scientists. But you also, 9 of the questions that you said about in the survey, the first one you showed, were like, how do I use Earth Engine better? That's a person who's responding to a signal that says, there's a market out there. I can get hired. I have a job, and I need to bring that skill forward. That's an engineering readiness question. And then the third one is, it's all these other people that have nothing to do with those 2 fields, but that are going to touch the same set of questions because they're going to be users. Thanks for coming to my TED Talk. I'm all done.
So thank you, Andrew. So I it's a bit remiss of me. I should also say thanks to OGC and UN-GIS and WGIC for helping assemble these speakers. It's quite telling that even just from the 4 speakers here, we have a range of people who actually work in a company and teach, or work with companies and universities. What Andrew didn't have time to say, and I'm not going to ask him to speak again, but they do have a very large program where they take on a lot of graduates and students and others. And then I think one of the things that came through really strongly is this understanding of infrastructure. So infrastructure elements, whatever infrastructure means, and that means different things to different people, and how from the knowledge, from the infrastructure, how you do the knowledge transfer and the value extraction. So that became quite clear. Think about, as Frank was saying, you need to understand models and be generalists, but you also need to know the limitations. And I think that's really important. And Daria also sort of covered that in a way by saying research is fine, but you also need to do implementation and you need impact. So we need to know where is that line between the two. So we need to think about that as well. The importance of IP and open source frameworks. Again, something that maybe I've just spent the last 7 years at GEO at the Group on Earth Observations, and trying to get anyone to talk about data licensing is like pulling teeth. So I know from firsthand experience, it's not very sexy, but it's really, 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 really important. So thinking about those topics is something that more research and more work needs done. And then Andrew talked about, you know, the pipeline of talent and having a broad range of skills and knowledge. I think all of what you've heard from Taegon and from everyone else is leading towards impact. So what is that journey towards impact, and how do you define impact, and what are the requirements to reach that impact? So I'll just finish on what Andrew said, to think about interface and index, and then you can listen to his plenary talk tomorrow. But I think that was really useful. And congratulations to everyone except Andrew for doing it within 4 minutes. Thank you very much.
Okay, so thank you. And now I don't know if I need to say that there is a break, but if I say that there is a break, probably people won't come back again. So I won't say that. And you, Andrew, will stay here with us for the discussion. Okay, no, obviously I'm joking, but if possible, I will ask you to have the discussion now, because in any case, there is the coffee, the bar is not closed, and so not near here. And so we need then to finish later. So if you resist, we can discuss now. Andrew?
It's not up to me.
Okay.
How do you guys
Okay.
feel?
Okay.
I'm kind of keen to hear from everybody.
Okay, thank you. So now I don't want to comment what was said, because I want to leave the people commenting and have their say. So please, now the floor is open to you. Whoever wants to speak and say something.
Hi, everybody. I'm Erin Stein. I'm with Two Sigma Data Clinic. We are the pro bono data and tech team of a financial sciences company. And I lead our partnerships. So I'm not one of our geospatial experts, but I'm kind of like the translator between our nonprofit partners and our team of experts. And I love everything that everybody said. I think I would just add, especially Andrew, one other person, because it would be great to have, you know, a more accessible way to pull insights from geospatial work. But I think there's still a generalist capacity building needed for the general social impact sector to help them understand how to ask the right questions or how to ask meaningful questions. Because the majority of my work happens when a nonprofit knocks on our door, they don't even know where to start to kind of organize their thoughts and articulate a meaningful question whose answer will provide value to their work. And so I have my first job is essentially like capacity building of general like data science topics, and what is data, what is good data, bad data, complete data, incomplete data, and what are the kinds of questions you can ask of what is available. And I think that's going to be similar for geospatial questions, but there's going to have a slight twist on it, as like Lokedra was saying. So in this idea of who are you building the curriculum for, I think there's a curriculum for the multidisciplinary scientists and experts. And then there's also a curriculum for the social impact sector to give them the base knowledge to know who to reach out to and how to have a meaningful partnership. So that's what I want to share.
Hi everyone. So I'm Fabrice, and I run a data consulting firm based in Côte d'Ivoire, in Ivory Coast, in West Africa. And I have a lot of questions for you guys, but like I will start with advocating for something. So I think I'm one of the only representatives of West Africa countries, and I want to my advocacy will come after your question. You said it's very important when you talk about capacity building to identify who we are going to train. And I think something that is unfortunately true is the fact that Africa, and especially some part of Africa, especially Francophone countries in Africa, I think are left over here. But I think it's really important for us also to think about that part of the work, because a lot of problem has to be solved there. For example, like if you want to monitor the deforestation in the Basin of Congo, I think at some point it's going to be important to have people going actually to collect ground truth data or to build model there. So for capacity building, I think it's really important to also think about the bias and the distribution of where the capacity is really present and not present, and where it should be present. So especially in Africa. And if you give me more time, I will ask a lot of questions that I've prepared, but I don't want to monopolize so not to speak too much.
Can I just quickly intervene? There is an initiative called Digital Earth Africa that has 9 implementing partners around Africa, including West Africa, and the data is all freely and openly available.
You mean the initiative is to collect data or to build capacity?
The initiative uses Landsat and Sentinel,
Yeah.
ALOS, and a few other data types.
Yeah.
And Planet is part of the sandbox, and it's already building algorithms and methods like water observations from space, like crop mask. There's a whole pile of stuff there.
Yeah.
It's 3 years old, and it's just got funding from all 5 years. So I can speak to you offline about it. I'm on the government.
Yeah, that's really great. And actually also I was thinking about stuff like building capacity, like helping local university, for example, to have like a PhD or PhD school specialized in geo AI. So I mean AI, the AI part of component, and also the Earth observation. So to give some background about myself, so we started a company, and we are a machine learning, deep learning company. And we just started a few months ago to work on Geo AI. So like we had to train ourselves, and we are still working on that on Earth observation, and working with Sentinel, JEDI, all this type of data. We are learning, and it's quite interesting because the problem we are solving with that are very, very, very interesting. It's even more interesting than working for the finance. But I love that.
Thank you very much. Yeah, I'd like to add that we will run the 2023 competition on the Zindi platform,
Yeah.
which is in Africa, and we have been submitting a couple of problems as an example for crop mapping, and we were assuming that we could easily instruct the people to use Google Earth Engine and to access the data directly from that platform, but they mentioned that it would be better to have the data not in that platform, because they have experienced the fact that the participation rate is much higher if you have the data available. So yes. we were a little bit surprised for that, but we think that is a sort of capacity building also to have the data in the platform and to have people learning how to access it.
Yeah.
I just wanted
I completely agree.
to mention this.
It's funny because last year we also run a competition like yours on Zindi. So the idea was to use Sentinel-2 data to predict biomass in cocoa plantation in Côte d'Ivoire. And we came up to Zindi, gave us the same advice, like don't leave the data somewhere, not pre-train and everything. So you have to pretend if you want as many participants as possible to take part to that, because you don't have knowledge background in Earth observation. It's important to pre-train, to process the data first, and then give them just access, because a lot of people have some knowledge in machine learning. So now you want to attract people from the machine learning part into the hard observation. And so that you have to,
Right.
you have to do that.
So I think that what we want to do is really to bridge the gap a little bit between the two communities, the geospatial community and the machine learning one.
community. Yeah.
Okay.
Okay. Thanks.
Thank you. Yes, please.
Hi, everybody. I'm Sam Arundel. I'm a research scientist with the U.S. Geological Survey. I'm not a geologist. We actually are data providers. I work for the National Geospatial Program. And the data that we provide include elevation and hydrography data for the country. Some of you may have used some of our data. And this, I'm here because this really is, well, two reasons. I come from academia. I was a professor for 14 years in geography. And then we also recruit in our science group. We have recently recruited for a Geo AI scientist, which was a really interesting process that took us 3 years to finally get somebody who even knew what the word was. And I think this is, it's a symptom of this bigger picture that we're talking about. And it was really interesting to see the results, the 50-50% computer science geographer type, because that's what we found. We have access to computer scientists nearby. And so we wind up doing the geospatial training a lot, but we also do go the other way around. So coming back to really the big picture of why we're here, and what Andrea just said, which is how do we put these, how do we merge these two different aspects? And it really brings me back to the early years of GIS, back in the late 80s, 90s, where we had similar. In geography, it was, do you need to be a programmer too? Do you learn geography and programming, or do we get the programmer, train them the other way around? So I'd love to hear some answers as to how we do this. I wonder, I have a question for Daria. You said you had a bunch of spatial data scientists, and I want to know what a spatial data scientist is and what their background is and how they got to be spatial data scientists.
They actually just do that degree. So UCL is one of the universities who offer this spatial data science. So it is around machine learning for big data mostly, which is really convenient for us because we handle quite big data sets. And of course, all the geospatial basics I mentioned earlier that can come back and bite you in the butt. You know what you're doing, like what are the reference systems? Because, for example, what we do sometimes is we use drone flights, high resolution drone flights, as part of our snow validation. And then, of course, we want to compare that with our product with simple language. So if you don't really know your projections, don't know your reference systems, then the whole thing can go out really quickly. So it's actually that combination of programming and geospatial that we mentioned earlier. But I don't think there are that many degrees out there that provide the same education.
So that might be a place to look for the beginning development of a syllabus.
So we have geoinformatics engineering, which is given both for students of computer science and environmental students. So they need to have the bachelor in environment engineering or computer engineering, and then they can attend our Master of Science, which is geoinformatics. It's exactly in between computer science and geomatics. So there are some cases around.
Yeah, we have this in Germany too, a lot.
Yeah, yeah.
But it's also, it's a strong focus sometimes, for example, on
sorry, Erin. E-R-I-N. Erin, sorry, it's my funny accent. I can't. That guy with the beard right there. That one. He's from a company called ESRI. And in 2010, we jointly did keynotes, not him because he's much younger, but someone else from the organization. I did a keynote at the START network, which you might have heard of, about exactly the point you said. And here we are 13 years later. And so I think what Andrew said is it's got to be a whole scale change, because it's the same old stuff that's just going round in circles. But the reason I'm pointing out Esri is because they do have about 20 people working in this area, and they're already working with a lot of people, and they do what they call mixed source, so open source and closed source. So have a chat with him. Réseau means network in French, so I'm always connecting people. So there you go. That was for free.
So my name's Eric Shook. I'm from the University of Minnesota. I'm also co-lead of education and workforce development for a $15 million US NSF project called iGuide. So I'm on the other side of this. Actually, I was furiously typing notes as everyone was talking, because we're actually developing a curriculum right now called the Convergence Curriculum for Geospatial Data Science. So it's a little bit broader than Geo AI, but we've been trying to collect user input. Some of you might have received some of our email blasts and things like that. If not, feel free to contact me. I can put you on the email blast list, but mostly we have money. We are actively working on curriculum development right now. Everything that will be developed will be open. So I'm on the other side, so I'm very curious in terms of hearing what the needs are and everything else. So I just wanted to toss that out there, but how can we contact you? Yeah, so I have a few business cards. Otherwise, yeah, I can leave email or LinkedIn or something like that. Yeah.
Okay, so thank you. And oh, sorry.
Just a quick intervention. So Brendan O'Neill, I work on Esri's nonprofit and global organizations team. I'm also adjunct faculty at Johns Hopkins University and teach a bit there in geospatial science. Just some observations of what I'm seeing with Geo AI in both the user communities that we support and on the academic side. I think there's a couple things on top of mind that should be incorporated into curriculum. One is, knowledge around the existing models for inferencing satellite imagery, for example, that are already out there. There's a ton. We're curating a bunch. I'm sure there's a bunch that are out there as well. So making students aware that they're out there, making sure they know how to use them in their own work, as well as understanding the uncertainty around that as well. So validating the models that are there for the purposes that they're applying, I think is one. That's probably the lowest hanging fruit, being able to apply GeoA models that are out there now. I think the other side that I see is, building on that body of knowledge. How are you able to improve the models that are out there or train your own models, so that the methodologies and workflows for creating your samples, et cetera, to train those models that are fit for purpose for your context, for your geography, I think is another side of things. And I'm thinking more around the kind of traditional geospatial analyst type, as opposed to maybe more someone who's focused on artificial intelligence as a discipline, and really has a deeper understanding of CNNs and things like that. So just those two observations. One is applying what's already out there, and then refining and training models that are fit for your own purposes to advance whatever discipline you're in. That's it.
Yes, thank you. So my name is Céline Rosenblatt. I am from the University of Lausanne, very close to here, Geneva. And so I am as a chair of the UN-GTIM societies, geospatial societies as well, representing IGU, International Geographical Union. So I am professor of geography, and in Lausanne University, we develop as well a master in environmental science with a lot of machine learning capacities. And Jin-Yang Yu, who's here, is teaching with the professor of climate and machine learning. And they also make a lot of machine learning with the Earth observatories. And beside, we have a master of human geography. And we have a small part on spatial analysis and statistics. And here also we try to develop that, but I would say that it is much more difficult to find relevant professors and interested students who could have the socio-economical interest, but also the computing capacity to mix all that. And most of the time they think that they are not able to do that. So we have very few students, but I think it should be much more developed, specifically for socioeconomic studies, and not only for environmental studies. And even we should mix also both. And even in geography, we always say, well, we have to not distinguish, separate human geography and physical geography, but in fact, the people in the practice, they do that. And this is a pity. And I think that socioeconomic data should be much more integrated in all these approaches, but it's very difficult.
A few words from what the colleague has said. I think it's important in the curriculum that we want to build around Geo AI stuff is what he said about the dealing with uncertainty and data quality in general. Because I think that's something that surprised me when I moved from other fields of AI to geospatial data. The fact that I think we are really closer to the physical world. We have to also put the knowledge of the instrument, for example, that are used to collect the data. Because usually when you work with financial data or you work with text, you don't deal with that. Now you have to know maybe how the instrument are calibrated, the resolution of the instrument. You have to add it when you give the prediction, to add it to the uncertainty, everything else. I would love to have in curriculum stuff about that, though, putting a very really good importance on that curriculums.
No, I don't want to close because we have time. No, I wanted just to comment first of all to you that in my opinion, it's really interesting what you are offering. Also because then I don't want to speak for AI for good, but we have the idea of going ahead with the series of geospatial. And so if it is possible also of considering for everyone in the world of providing some lectures and training, which will be made available by means of this organization, in my opinion, this will be much probably also better for you because you have more visibility. And Andrea, I believe that we will go ahead.
Yes, we are definitely willing to assist you in all the way that we can.
Okay, so in this case, if there is something that can be reused for everyone, that is very good. And also because I believe that it's, for me, it's impossible to say, I will prepare a course on that and the course will be complete and I will be happy. It's too much and the technology is evolving too fast. So it's much better to agree that we can share on duties and say, I will prepare this, you will prepare that, and another person that one, and giving to all our students. So this is my vision, because I know that I have not enough time for doing that. And I know that there are people that can do definitely better than me. So why I need to do if there are people that can do better than me? So thank you very much for these for what you proposed. We have to speak about that. Yeah. And then I have a comment with for you, because in my opinion, even when we teach something related to GeoAI or AI, generally what we do, because we don't have enough time, we give to the student the data that are already prepared, clean the data, everything, the results will be perfect. And we say, we prepare before the data. Now you run the different algorithms, you find the best one. But the life is not such. So in the true life, they will have data that are not cleaned, data that sometimes are partially garbage. And so probably thinking about these syllabus, we have also to focus on the value of data and teaching the people how to deal with the data, how to clean data, how to clean big data specifically, because now we are speaking about big data. And therefore, in my opinion, the point of the data is very relevant, because it's something that for lack of time, generally, we don't do to the student, or just in the thesis or something like that, but not in the normal teachings. But in my opinion, it's very relevant to this point. Yeah.
So building on what you just said about, using existing stuff, and also to your point about, I guess, origin and quality and stuff. I mean, and also because we're an ITU, there are standards. I used to work for OGC. So sadly, I've read all these, but there's ISO 19137, ISO 1938, 115. All of these exist. And so there could almost be a modernization, maybe through OGC and their collaborative work, to update some of this stuff in line with this discussion, so that we're not it's kind of to your point about, coordinate reference systems. Let's not go changing things that work particularly well and that would completely disrupt the work of Esri and the work of Planet and others, because we have people coming in all the time to the industry trying to change things that are very well established. And, you can't really, well, you can if you're a flat earther, but we shouldn't really be changing the shape of the earth and things like that. So I think looking at what already exists could be strong in terms of a contribution to content, but also modernizing or updating what is there in the context of this discussion.
Are we allowed to keep going, or are we?
Yeah. Just speak.
Okay. Just a small point. I think about you're developing. I live 100 meters from the front door of the University of Minnesota.
We've been in meetings.
We have. I was like, looking at you, going, you know him. Anyway,
you're my favorite.
Yeah. Okay. So the thing I wanted to say was that the thing is, this field, it's been improving, but it's a little bit like plotting the future course of a river, right? You're right at the point where a waterfall is about to hit. And so the world's so let's take data quality as a good example. Like everybody here, if you want to get a cheap laugh, is just make a joke about data quality. Everyone is, I have gray hairs because of spending 90% of my time in a project doing all the work before the project, right? To get ready to do the project. But the infrastructure, commercial and otherwise, is moving us to a place where that should diminish, because we will never get the promise of GeoAI if we are requiring, it's a tractable problem now. And our organization is producing vast amounts of ARD, and we're just one of them. So then the question, though, that's really interesting is, we're going to, we see a huge amount of work developing new classifiers. We're going to classify the Earth. So we're going to find all the carbon and the water and the roads and the buildings, and then a whole bunch of other things that don't make sense in Western ontologies of knowledge, like just the way that the way that I classify the world and the way that we might communally classify the world in this room might not be the way that everybody working in the forefront work that you're doing classifies the world or sees the landscape in the same way. Okay, so like the design of classifiers and the kind of human in the loop refinement of classifiers is much more important, I think, because it's like where the future of the wave is. Then how do we do the data cleanup, which the market, and I don't mean just the commercial market, but the larger ecosystem of actors is working on fixing and making better. It's not all the way fixed, but I feel like it's, you know, it's improving dramatically.
I had hair before I started doing that. Yeah, so this is actually usually my fight in curriculum development meetings with especially traditional GIS folks, is no one wants to dump anything that maybe is less relevant, but somehow we have to make room for all of this new stuff. So I think that ends up being a really big challenge in the curriculum development for sure. I think that we have to recognize that different people will want different amounts of these things. So you really have to build it to be a bit modular, because I would assume if I queried every single person in this room, you all have a different spectrum of terms of how much you care about data quality, how much you care about, you know, reproduction, replicability, these sorts of things. So I think that we have to be thoughtful about that, but I would agree. I think it's really hard to think through what it should be, but it's coming for sure. Also, we are building a library of open educational resources as part of the project as well, because we don't want to reinvent the wheel. Time is limited, so if I can use other people's resources, I absolutely will. Saves me sleep. So that'll be available as well.
Yes, I think that the classification is very a key issue, because behind each classification, there is a way of thinking. There is a model of thinking. And most of the time, this model is not explicit at all. It is hidden. And working on digital twin cities, what I see is that engineers, they build architectures that have a meaning, but they don't know even that there is a meaning behind it. And this is the worst, I think. So behind each classification, each knowledge, each information construction, there is a knowledge. And this knowledge is in science, is in history of science, it is in epistemology, and I think this is very important. Also, when I spoke before about natural and social information, of course, there are many, let's say, visible information that we can classify from satellite, from different captors. And what about invisible information that we can also classify? But here you put even much more interpretation of the meaning. So the thing is the goal. Also, you put the meaning because of the goal you put in your study, and this is very important to be explicit, I think.
I just wanted to add a few things about Andrew, after Andrew's intervention, and I completely agree, and I will be a little bit pessimistic because the way I see the research growing in Geo AI is the same thing I saw the research and the products being developed in AI. So I think products are built, or development research is done to solve Western problem, unfortunately. And for a personal reason, actually it's why I decided, so I did my study in France and I was working in France, and I decided to go back to Africa to create my company there. At some point, because I was doing NLP, so AI for text. And in 2017-18, Google started implementing transformers, so AI into its product. And Google Translate at that time, there was no African languages. I was like, okay, Western company like Google's are going to build products for Western. So we have to develop our own capacity in Africa if you want to build products for Africans. And that's why I decided to go back there. And I think it's actually what I'm seeing for Geo AI too. And unless the fields change, and I'm pessimistic, I don't think it's going to change like that. Unless we decide to change, but I think the only solution I find is to develop capacity in Africa so that people can focus on the local problem. This is like, maybe I'm wrong. I don't know.
Thank you. I'm trying to collect my thoughts after all those good comments. I think there's for me as a geographer, I'm probably not one professor as all of you, but it goes back all the time to the geography and how it applies to different technologies and how we keep on reinventing sometimes some things around geography, machine learning and AI. Okay, important is to have interdisciplinary. Okay, that's geography. So it goes back to geography. And I think in considering syllabus and what needs to be done, I think Esri does it really well also to build different curriculums based on the audience that you want to have. And of course, for university, it might be a specific audience, but it might be for, more engineering departments and for geography departments that there is curriculum that are different to customize for maybe more in-depth, more topographic, engineering, geological surveys, and those types of curriculums on GeoAI and the tools and so on. For geographers, we do statistics. I did also some programming, et cetera, painfully, but at least I have a common language with possibly engineers and so on. But maybe, and that's, I think, was mentioned before, maybe we haven't considered how we should have also curriculums for maybe decision makers, governments, and higher levels, and be able to hit on that impact perspective and try to make it a little bit more understandable for everyone how all those technologies, whether it's digital twin or whether it's the AI or whichever the new buzz may be, that we have those kind of interface that is going to help them to, as it was mentioned before, formulate the questions to be able to, do what they actually want to do. So that's maybe food for thoughts to consider different types of syllabus. I think also the domain of applicability of all those of geography and it applies to so many things. So this is why you can put geo in front of everything. I'm sorry, everyone as well, but of everything. And you have geo AI, but you could have geo digital twin, and we hear about, and it's also, we did a small survey in the UN about who's doing GIS, who's doing geospatial. And a lot of people respond, but you see the job title of those people. So going back to the job title is very difficult because some are data scientists, some of them are researchers, some of them are GIS specialists, some of them are engineers, depending on where it came. And the network that we created, the UN Geospatial Network, it was very difficult to identify all those people GIS. So we said, okay, so whomever is using some part of geo can respond to this survey, and then boom, we had 400 people responding. But it doesn't mean that they do only geospatial all the time and that there's a specific need for that curriculum. Maybe there's a need for that kind of customized approach to things, including for decision makers where they can make the impact on some of those things. Thank you.
Good afternoon. My name is Peng Yuhao from Food and Agriculture Organization of United Nations. I just want to follow just now Andrew talk about how we classify the world, and we are now actually facing the same problem. Is we are doing the work about global cropland existence mapping, and we have 5 or 6 global mappings at 10 to 30 meter spatial resolution, but each data have their own definitions of cropland. That's a disaster for us because they have large disagreement. They are not sure the disagreement is caused by the definition difference or caused by their misclassifications. So this is the reason why we are now proposing a GeoAI challenge with Maria and Andrea to map the global cropland extent. We have the challenge last year, and also we have it in this year. So now FAO have our own definition of cropland. It is the combination of the cultivated land and the permanent cropland, and the data is used for the global statistic. So I think for us, if we need firstly before the AI, we need a clear definition of what we need to do, and then after we have this definition, we should using AI to achieve our data site. And finally, is we have a lot of different data site. So we need a good validation of the data site to control the data quality and to see which data is most suitable for our use, because we use data for a long time series analysis. So this makes the data make sense. If the data doesn't fulfill our requirement, doesn't have good validation result, and they do not have good definitions to make sense, it means that this data set is useless. So this is what we are trying to do, to have a clear workflow to define good data and to have good data set for the community. That's it. Thanks.
You've all learned I like to talk. So could I just add one thing to that very briefly? I think it's fascinating for your curriculum that, you know, there's no definition. There's a definition of what a tree is. We know what a tree is. We know what carbon is, but we don't actually have a common definition of what a forest is. How my community defines a forest and how your community defines a forest and how your community defines a forest, we're all different. And I say this because we have a huge program our organization runs where we provide comprehensive data about all the forests of the tropics to 64 countries as a global public good through FAO, specifically through CEPOL, funded by the Norwegians. And the thing that's been critical in that process is to design structures that allow for a common data set, but multiple models of interpretation. And the heterogeneity, what it really impressed upon us was how all of those because those are social and political and cultural considerations, their value, they go to core issues of sovereignty. And in a world where some of the most important work in conservation of these specific places are done by indigenous peoples, if the structures don't have, if there isn't a process by which those kinds of knowledge structures can be made to fluoresce in the system, can be brought forward and kind of live in equity with all of the other interpretations. Like FAO needs a definition for agriculture, I understand, for croplands, but we need to build systems that also allow people to say, this is how I look at croplands, in a way that doesn't disenfranchise or privilege any specific voice, but it allows for utility. And I think that's a principle, like it's a design principle for these AI systems that would be amazing to teach. It's not even as an ethical principle, it's a practical principle, because then you can build the world's best Geo AI system and have it land with a thud when people say, that's not, you've encoded all of these things that just encode all these institutional biases.
And I build on that by saying everyone talks about fair, findable, accessible, interoperable, reusable, but who do you hear talking about trust and care? Those are two other frameworks. So when you're building, you need to look at all of the options so that you're not missing something out. And it's not, like our friend says, a very Western view of thinking.
Yeah, that's just what I wanted to add in, which is kind of the idea of data quality, who defines what these various classifiers are. It's a completely influenced by your culture, your politics, your background knowledge. And those are decisions that we can't just purely rely on partners to inform us about, because not every piece of geospatial science is done with a local partner to in every single context. That's the ideal world, but in reality, it's not. So we have to, just like with ethics, as you were saying, Maria, is we kind of like embedded in everything, a general understanding of the sociology, history, politics that influence geospatial data and decision making is crucial for anyone involved in the field, I think.
Yeah, I just want to say what we're talking about here is basically the field of ontology, right? So there's experts who specify the specification of a domain and how the specification can work across domains. So just, I don't know, I see you going, nah, I don't know, but so it may be something just this group would want to look into, because there has been a lot of work and a lot of people dedicated their careers to understanding this very issue of, and especially working across cultures. So what word in this culture means something in that culture. And so there's standards that have been developed around that, and lots of work, so.
Okay, so thank you. Yeah, but I have one question for you, because speaking about ontology is not something referring only to AI. As a matter of fact, we have spoken about ontology for 20 years. We have metadata already available, and we know very well that there is this question. So it's not just one Earth, but we can speak about many Earths and so on. So this is, but in my opinion, this is not typical of machine learning, so of AI. Is not only AI. We are speaking about geospatial in general. But I want to focus better on what we have in the intersection, if there is something new in the intersection between geospatial and AI. Because if it is just ontology, we have already body of knowledge speaking about ontology. We have already courses about ontology. But is just that, or there is something more?
Well, I think right now we actually are at the forefront of figuring out what we need to do with ontologies. Do we need ontologies anymore? If we have natural language processing, they can interpret what we're saying. And I think that is a great question, what you're asking. No, not just ontologies. I think that's a wide open field, and where we're going with that, with ontology, NGO-AI, and AI, all of those integrated across large language models. I don't know. Does anybody know where we're going there? I think about it all the time.
If I will not answer directly, but
no, you have to answer
I think this is a very important point. It is a kind of opposition between structured and unstructured information, and the way we build knowledge. And I think that we build knowledge with a kind of structure, unstructured information, maybe. And so how can we mix and combine these two kind of information? For example, with semantic web on one way and natural language on another way. There are also many debates on that. And yeah, the question's still open.
So may I say something very practical? if you like it, because I'm a very practical person. As there is an interest on this topic, are there also people here who want to deepen in more into that and preparing some lessons about that for us and for the students? I'm not the person because I'm more engineer on the other side. So
I think the point maybe just it could be part of a curriculum or at least awareness of these issues. Could be part of a curriculum.
It could be part.
I'm not an ontologist, so
yeah,
don't look at me.
No, it could be part. No, it's very, in my opinion, it's interesting, this point related to ontologies, language machine learning, and so language is very important. I'm not the right person for working on that. I say explicitly because I'm not working, I'm not doing research in this field, but I believe that is important. And therefore, for going ahead with respect to what we are saying, I want to understand if there is somebody, could be also online, not only here, who is interested in deepening work here.
I'm not volunteering for that. I got out of social media analytics because it became too focused on ontologies, and yeah, that's not me. I'm not a words person. However, if somebody wants to do it, I'm happy to incorporate it. I do think that what Andrew is saying is interesting, and I do think that this is going to come into play, especially when we're talking about foundation models, because foundation models are going to be built on English-based Western understandings of the world, right? So if we put all of our GeoAI interpretations on top of that, there's no way that you're going to be able to break that, right? I mean, they're called foundation models for a reason. So I do think this is important, especially as we're talking about foundation models for GeoAI and these sorts of things, is that, I mean, you're basically just creating the system. And once that gets established and that becomes a standard and it goes through OGC and all the other standards bodies, that's what everybody uses. And then we've just reinforced the entire system. So I agree. I don't have a solution for it, but I do think that it's interesting and something that we should be paying attention to, if nothing else in the curriculum, to make people aware, so that if somebody's smarter than me that understands ontologies can come up with a solution, that would be a good way to do it. But I think you're spot on with that, Andrew.
So I'm not volunteering either. But I went to a little American university called Stanford, and I did an executive leadership course on digital transformation. And they taught us stochastic modeling, linear regression, random forest, and this was for very, very senior leaders. I mean, I paid for myself to go on to pretend I was a leader, but all these other people on there are like earning millions of dollars per year. And it was hard. It was maths, it was statistics, it was a lot of stuff. And it was really incredibly useful, because now when I speak to Pictera, I know what the hell they're talking about. But I think that part is missing. And it goes to your comment about policymakers. I think at that level, there is a gap of people who are doing the work versus the people who are making very, very big decisions, who have no idea about what's coming. So I think I would go back and start to look at what Andrew was saying about definitions and language and all of that, and what Frank was saying about understanding the model. I think that's really crucial. And so there's a good time now to educate people about what do these algorithms mean, and then to Erin's point about where are the biases in those algorithms.
Hi, everyone. My name is Emily Sespico. I work for the Atlantic Council. It's a US-based think tank. Specifically, I work with our Geotech Center. So we work with design, development, implementation, and regulation of emerging technologies. AI is one of our big ones. Space and satellite technology is also one of our big ones. But I think a couple of people have said they don't volunteer necessarily for these programs, but I might step in and volunteer. One of our biggest programs right now is a global capacity building program. We span 63 different countries, and we work on connecting policymakers around the world to responsible AI, I guess, outlines that are already in existence, and also connecting them with local technicians and engineers as well. So we have been working on this project for about 1.5 years at this point. We have a series of webinars that are available online. And essentially it's kind of from we start with the basics and we work from okay, so these are the regulations that are in existence, then maybe the guidelines that you should follow that are out there. We work with OECD, AI responsible AI principles, and then moving into kind of like the implementation and the applications as well on kind of more practical level. And I think some of the most successful parts of the workshops and the program that we have is when we dive deep into each of the individual projects from either a policy side or the technology side as well. So we have, you know, specific workshops dedicated to NLP. We have specific workshops dedicated to the regulation side of things and the responsible development and applications. So, you know, if it would be, you know, I'd be interested to talk with you about your program as well. But, you know, to have conversations about how we can maybe build sort of similar program. It's really interesting to hear. Thanks. Correct. Yes. Yeah. So our case is AI in general, but it's definitely, you know, a program outline that can be applicable to a lot of different ways that we could dive into in more depth in the future.
Also, because if already exists a backbone, the point is if we can be interested in adding something which is geo to this curriculum.
Yes, we would be very interested in doing something like that. So we'd be happy to talk with anybody further.
Other comments?
If I may.
Yeah, sure.
Hi.
Anna Lokedra, you spoke too much before.
No, I just wanted to add a small line that in the last OGC meeting this June, we had a discussion on the exactly same topic of like, because NGA was trying to work on a new standard using, and they developed very deep ontologies, etc. And the discussion veered into the same topic where would these be relevant, or how should we look about it, like considering the foundation models and NLP models may make them redundant itself. So yeah, so you may find some more collaborators there also. That's all I wanted to say.
Thank you, Lokedra. Meanwhile, sorry, I want to read because there were also some comments online, and specifically there is Stephen Castellane saying that they have a body of knowledge which is they're currently collaborating. Probably I'm missing something because
which is important for classification.
Which is can be important tool for the classification, as the panel is discussing. It provides a shared vocabulary which allows all of us to speak the same language as a basis to, for example, build curricula or comparable learning unit. Okay, so there is this body of knowledge which is in general about geo, and that was developed by EO4Geo, which already is explaining, or it's putting some standard with respect to some topics, and therefore the recommendation is, if we want to do something, to start from there. Okay, thank you, Sven. So just to try to summarize, speaking about these syllabus, or better syllabi, we see at least two different levels. One level for decision makers and one level more for technologists, shall we say in this way? Because my students are engineers, sorry. So I'm interested also in what to teach to engineers. even if I believe the first level for decision makers is very relevant, because in fact, those decision makers have to understand at least what they are, what they need, what is available, and so on. So, but at these the two levels of syllabus that you see, or probably the second one is not only technological, because we can consider something that is more, I don't know how to define it, more, help me in the definition.
Maybe there are people who develop, or developers, and people who are users.
Yeah.
These are two levels. So the users maybe could be from other disciplines.
Yeah.
Sociology, anthropology, right, economy, cultural heritage. Yes. But they only use that, and more specialists who would develop it.
Maybe that's where you want the technologies of the developer to have some sense or a bit of knowledge on the social aspect, the bias that they will bring in the model.
Okay, so we can think about giving this term users and developers to the two levels, even if sometimes users are developers of data. And so,
Sorry,
okay.
I just wanted to keep the door open. Maybe.
Ah, okay, yeah, thank you, thank you. Just to survive, just for survive. Okay.
I wouldn't. I like the idea of decision makers and then technologists, but then I kind of feel like the technologists are split into two main users. Like, I think I can't remember who said it at first. Maybe it was you, Maria, like the analysts and then the scientists building the models. And then, because we see it all the time in all of our partners, is that there's fairly a knowledgeable technologists at a lot of social impact orgs, but they don't necessarily have the training or understanding to like build new models or retrain models. So, but they are going to use those models that others have maybe built for them day in and day out. So they're kind of more on the ground than the decision makers, who just at least need to understand at a higher level in order to like ask the right questions or understand how to implement that in a larger picture. So that would be my proposal.
Yeah, I was thinking kind of along the lines of builders, appliers, and deciders. And then, so people in a domain are more likely to apply the technology. So I think of like back in the day, we used to teach a general like master's level GIS class that anybody across campus could come into, because they might use the technology at some point within their domain.
Is it engineer, geographers, and politicians?
Yeah. So the builders would be the engineers, but I think you can have, I think you could have geographers in that domain.
Yeah.
Studies geospatial technology, geospatial engineering, so in the middle.
Right. So maybe more on the applier side, because they're not, yeah, so complicated. There you go.
Because we have in mind the concept, but then we don't have in mind the specific student and then practitioner doing just this or that. That is the main. So we have clear the extreme. So the extreme as builders are the people only developing the right. But there is something in between, and also sometimes the people taking decisions, so they can be also technologists, and so. But we can also only reason in the beginning, try to cut in these different syllabus. syllabi. And then if we are able of creating this syllabi, we can discover that there are some people in between, that people in between can decide to take something from here, something from there. Yeah. So it's good, even if it is not perfect, let us say in this way, considering these 3 classes.
Maria?
Yeah.
Maybe it's useful to think about what outcome you're trying to achieve rather than who the person is or what their role is, because different people across different roles might leverage the same methodologies. They could be kind of universal. And, back to my point earlier, I think there are people in different disciplines that are going to be applying models that scientists who train the models are developing. And to a certain extent, they might be retraining those models for their specific geography, for example, because we know that Côte d'Ivoire is going to be very different than Geneva. So I think there's kind of that application of models, but then I think there is more of a deep science approach. It's like the people in this room from Pictera or SI systems, where they're actually, developing the algorithms, the technology that can then be applied to the different disciplines that are out there. So maybe thinking about it more from the methodology and what an individual is trying to achieve, and then those core methodologies could be applied to different programs as needed. Could be an idea.
Okay. Other comments? But I'm a bit curious about your curriculum at this point, because now we are discussing these 3 levels and blah, blah. And what about your curriculum, as you have experience on that?
Yeah, so we have a figure of it online, happy to share with anybody, but the way that we essentially built it was for a interdisciplinary audience. So the whole intention was what we call what US National Science Foundation calls convergent science, which is the continual progression of interdisciplinary, transdisciplinary, and now we have convergence. The idea was that we wanted to bring in domain experts, teach them enough geo, enough computing in order to do their domain science. We wanted to bring in geo people and learn enough of the domain expertise so that they could talk to the domain experts, as well as the computational pieces, as well as the computational folks to learn both geo and domain, so that you could actually have a convergent team. The challenge with that is that everybody needs something a little bit different. So each of our curriculum models is actually built at different levels, starting at 3 sentences. So for every single curriculum component, we have literally a 3-sentence description of what is geospatial analytics, what is Geo AI, what is geospatial data science, so that you can just ground floor what we saw at the beginning of these presentations of what are we talking about, right? And then we have 3 slides. So the 3 slides are something that anybody can introduce into a talk, a class, a workshop, those sorts of things. And then we pivot to a 3-hour module where you can incorporate that into a class. So the 3-hour module has essentially 1-hour lecture slides with lecture notes, figuring that the person who's giving it may not be a content level expert. It's one of the big problems that I run into in geospatial computing, is that lots of people want to introduce computing into GIS classrooms, but they don't actually have background in computing. So they're actually not very comfortable teaching the material. So we've been trying to be very intentional in including lecture notes, so that the content level expert who's developing the materials to share says, oh, in this slide, this is the really relevant point. Or when the students or learners need to do this reading, this is what I'm trying to draw out. This key point is the reason why we did this reading. And then a 1-hour hands-on activity, so that you actually are doing it. I'm also a very practical person, and my head, I'm a bad academic in that my head doesn't live in the clouds. Eventually everything that I do needs to turn into zeros and ones. So I'm a firm believer that you actually have to apply the knowledge. And then eventually we'll have 3-week material as well, where you actually develop this into a lengthy thing. So the way that you can navigate the material then is what we call multiple learner pathways. So, you know, you might need a little bit of geospatial, you might need a little bit more of computing, and you might need some or a lot of ethics or geoethics, for example. So the learner can actually mix and match, or the instructor can pick and mix and match different materials. So that's kind of how we've been designing it. It has been evolving. So if people have input suggestions, this is already iteration number 3. We've been trying to really build in community input. So it's definitely not fixed.
Just to explain to everyone, this is not a one course. This is a curriculum, complete curriculum.
Yeah.
Of how many credits?
So we intentionally did not design it as a 15-week 3-credit course because that just fails to roll out in pretty much any setting, because whether you're in engineering, whether you're in geography, all your curriculum's full, right? Or if you want to roll in a class, you want to create it yourself. So we intentionally didn't create it as a course. So each of the components build on top of each other, but you get to mix and match how you would want to use it. So it's modular in that way. So we don't assign credits. We are doing a digital badge. So we're exploring digital badges as small pieces. So we started that design 2 weeks ago. So which is going to be focused around kind of geospatial data literacy, more interpretation rather than analysis. Is just like a base level what you could give to a high school student, to a first-year undergraduate student, maybe a decision maker. I love the decision maker angle. I think that's important. So we're working on that as well.
In your case, because you say that you are also teaching, it is a teaching or it is a course of study? No, it is a teaching. What you do?
We have a main master graduate on environmental studies, which integrate a lot of machine learning, and for how the human side, the human geography side, it is an option of a master. So we have how many? I think we have something like 40 credits in really technical, and so data, models, and applications. We have 3 main modules, which contains about in total 10 or 12 courses. They have some credits. It's a one professor, one course.
Okay. The 10 of 20, you said? No, there is something that they didn't understand, because you say 10 courses.
Yes, 10 different courses.
About AI? No.
No, not about AI.
Okay.
Around geography, statistics, and there are some of machine learning integrated inside that.
Integrated in one course.
In one training. It's not one course, it is different courses.
Okay.
For masters?
For masters.
Master's program.
To wrap up. Oh yes, now it's time. Yeah.
It's Thursday.
Sorry, yes. Okay, so I don't know really if there is a conclusion, because we opened many questions. I believe that it was a good occasion for meeting, because now we know that there are some experience we can refer to. We know that there is already something existing. We can go ahead and collaborate and so on at different levels, also for decision makers. I believe that can be also of interest of our friends of the private sector, that can, in case collaborate also with this experience. I think that the only solution we came is that, but correct me if I'm wrong, is that we can't think of a single curriculum. We can start building a body of knowledge because this is something different, and we can start building a body of knowledge. We know that there are already body of knowledge general about geo, and therefore it's good to start from there. If we want to add something related to AI, collaborating also with the people, they offer themselves to collaborate on that, so it's good. But with respect to the syllabus, the conclusion by now is that we have to think at least to 3 different syllabi. One more for decision makers, and we can have some people who already have something to start from. One more for, we say, the people applying technology, the appliers, correct? So appliers, and one more for builders. Then it's not clear because we can say engineers, geographer, decision makers, but or politics, or but it could be that it's better to say builders, suppliers, and decision. So in my opinion, this is the main, at least the point we arrived. And then there was a lot of discussion about many points that are very relevant, in my opinion. So speaking about data, the ontology, how data can be seen a different way, ontologies in a different way, depending who you are, where you are, and so on and so on. But this is something that we already have known from our geospatial history. Simply, we have to put it also again in this part related to GeoAI. This is my impression. I don't know if you agree on that. We have to remember what we already built, the standards, what is already available. We have to start from there. We don't have to reinvent everything. There is a huge knowledge behind us. We have to start from there. And say that I can only say that personally I'm interested in going ahead with this adventure, and so the people who are interested here or online can contact me or Andrea, and we can start collecting people. Possibly, if there are many people interested, try to create some working group. I don't think that we need to ask people to do something new, something adding what they need to do. I believe that we have to start from what we are already doing, as a matter of fact, and simply try to share with the other what we are already doing for building this curriculum. So not adding extra work. I know that all of us, me too, I'm very busy, but if, as we have very, very different points of view, as a matter of fact, and knowledge and so on, expertise, if we are able to share it for building something related to these syllabi, in my opinion, that could be a good point. So people interested, write to us, and we will try to create some working group for working, deciding to work on this and that and that. So if you have good idea, if you send us your email, but I suppose we have your email. So if it is possible to reuse it, we will send you pieces of information if there are other people who are interested in creating a group, a working group for doing something related to this field. Steve, do you want to say something?
No, I'm just the host is very logical.
Okay, so thank you, everyone, and so
excuse me, the presentations will be
the presentation will be shared. Yes, the presentation will be available for everyone. Yeah, sure. Okay, So thank you, and we have still 1 minute, but I believe that we can close 1 minute in advance. Thank you for everyone. Thank you also for the to the people online. And okay, so the same message is also for the people online. If you are interested in collaborating, please contact us, and the slides will be available for everyone on the website of AI for Good. Thank you. Thank you.